Find the Laplace transform of g of t equals 0 if t is less than 1, t minus 1 if t is greater than or equal to 1 and less than 2, and 3 minus t if t is greater than or equal to 2. From the previous example, we already know that g of t is t minus 1 u of t minus 1 minus 2t minus 4 u of t minus 2. And according to the second shifting theorem, the Laplace transform of u of t minus tau times f of t minus tau is e to the negative tau s times the Laplace transform of f of t. So we need to rewrite the two halves of g of t in the form u of t minus tau times f of t minus tau. The first part, t minus 1 u of t minus 1, is pretty much already in the correct format. We can just switch the order of the factors and write it as u of t minus 1 t minus 1, which makes the function f of t minus tau just t minus 1, which is the function f of t equals t evaluated at t minus 1. So the Laplace transform of u of t minus 1 t minus 1 equals e to the negative s times 1 times the Laplace transform of t, which according to the table of Laplace transforms is e to the negative x times 1 over s squared, using the entry Laplace transform of t to the n is n factorial over s to the n plus 1. The second half of g of t can be written as negative 2t minus 4 u of t minus 2, which equals negative 2 times t minus 2 u of t minus 2, or negative 2 u of t minus 2 t minus 2. So the Laplace transform of negative 2u t minus 2 times t minus 2 equals negative 2 times the Laplace transform of u of t minus 2 times t minus 2, which has the form u of t minus tau f of t minus tau, where tau equals 2 and f of t equals t. So the Laplace transform of u of t minus 2 t minus 2 is e to the negative 2s times 1 over s squared. Putting the two halves together, the Laplace transform of g of t is e to the negative s over s squared minus 2e to the negative 2s over s squared, or just e to the negative s minus 2e to the negative 2s all over s squared.